In this lesson, we will be talking about the normal distribution. What is the normal distribution? The normal distribution, also called the Gaussian distribution, is a continuous probability distribution for a random variable. Its graph is called a normal curve, bell curve, or Gaussian curve. Its parameters are the mean and the standard deviation. The mean gives the location of symmetry, while the standard deviation describes the spread of the data. Normal distributions are also very important in statistics because they occur very often in real-life data when graphed. Here are some examples: lifespan of products, test scores, heights and weights. Do you notice anything similar between these examples? It's because they are all data measurements. Next, we will be talking about the different properties of the normal distribution. The first property of the normal distribution is that the normal curve is bell-shaped and symmetrical. The second property is that the mean, median, and the mode are all equal. This is because the shape of the data is symmetrical with one peak. We will only be referring to this peak as the mean. This value divides the data in half. The third property is that the total area under the curve is equal to 1. The fourth property is that the normal curve never touches the x-axis as it extends farther and farther away from the mean. Now, we will be talking about finding areas under the normal curve. We can find areas under the normal curve by standardizing every normal distribution. This turns it into a standard normal distribution. In order for us to standardize a normally distributed variable x, we must use the following formula, which turns it into a z-score. A standard normal distribution has the following properties. A. It has a mean of 0. B. A standard deviation of 1. C. Almost all the area under the standard normal curve lies between -3 and 3. D. The cumulative area is close to 0 for z-score close to z equals -3.49. E. The cumulative area for z equals 0 is 0.5. F. The cumulative area is close to 1 for z-scores close to z equals 3.49. These properties all lead to the conclusion that the cumulative area increases as the z-scores increase. Now, we'll try to find areas under the standard normal curve. Along the way, we will use a two-step method. Step 1, we will graph the problem. Step 2, we will analyze and solve the problem. Again, I have to note that because the normal distribution is symmetrical, we know that the area above the mean and the area below the mean are both equal to 0.5. I also have to note that area is the same as probability. Let's try now to find areas given a z-score. In our first problem, we'll try to find the area to the left of z. Let's say that our z-score is 1.23. This part of the area is 0.5 because it is half of the graph. This other part of the area was found by looking for z equals 1.23 on the positive z table, which is 0.3907. If we add them, then the area to the left of z is 0.8907. In our second problem, we'll try to find the area to the right of z if our z-score is the same. To find this area of the graph, we must subtract this area from 0.5. We know that from the z table that this area is 0.3907. So, if we subtract it from 0.5, we get 0.1093. In our third problem, we'll try to find the area between two z-scores. Our z-scores are -0.725 and 1.23. To find the area between our two z-scores, we must add the areas of each z-score. Using our z-table, we found that negative 0.75 has an area of 0.2734, while 1.23 has an area of 0.3907. If we add them, we get 0.6641.
Created using Powtoon.